Let's evaluate this integral, that is integral of ds over s squared times s minus 1 quantity squared. So first I'm going to rewrite this integral as integral of 1 over by the denominator expression, that is s squared times s minus 1 quantity squared, and then I put this ds. We are going to evaluate this integral by partial fraction decomposition method. So first, let's consider only this expression inside the integral, that is this expression. So I write down 1 over s squared times s minus 1 quantity squared, and using partial fraction decomposition, we can write down this rational expression as a sum of partial fractions. That is, we put the first fraction as a over s because we have s squared term. So we have to utilize one constant for the s term, and then we put b over s squared. So we place another constant for the s squared term now, and we also put another constant over s minus 1. This is just s minus 1, and we also put another constant over s minus 1 quantity square. Now to determine the values of a, b, c, and d, we have to simplify, and we have to remove the fractions on both sides first. So to remove the fractions, I'm going to multiply both sides by the least common denominator. The least common denominator is the expression in the denominator of the left side expression. That is, this is the least common denominator. So I'm going to multiply by this term on both sides. So when I do that, I put this, and this has to be multiplied with s squared times of s minus 1 quantity squared. So I should multiply this side. So when I do that, on the left side I should also multiply on the right side. So this will be s squared times of s minus 1 quantity squared, and multiply with the term which we have on the right side, that is a by s plus b by s squared plus c by s minus 1, plus the last term is d over s minus 1 quantity square. So let's simplify this. We observe that on the left side we have the same exact terms both in the numerator and denominator. So we can cancel these terms, s squared and s squared, s minus 1, s minus 1 quantity squared. These two will get cancelled, and we'll be left only with 1 on the left side. And when we multiply this expression, that is the least common denominator, with the terms on the right side, basically we have to distribute this least common denominator with all the terms inside the brackets. So when we do that, notice that we have this factor s squared times s minus 1 quantity squared, and when we multiply with each of the terms with each constant, we just have to do the cancellation. That is, this s and this s square will get cancelled when you multiply with this term with constant a. So a will have only a times of s times of s minus 1 quantity squared. And similarly, when we distribute this least common denominator with the b term, we will see that this s squared and this s squared will also get cancelled, and we'll be left with only b times of s minus 1 quantity squared. And for the c term, we will see that this s minus 1 will get cancelled with 1 power of s minus 1, and we already have this s squared, so let's not forget it. So we will have c times of s squared times of s minus 1. And finally, for the d term, you will see that this s minus 1 quantity square will get exactly cancelled with this s minus 1 quantity square, and we will have only s squared term. So d will get multiplied only the s squared term. Now let's see how to determine the values of a, b, c, and d. So first, I'm going to put this term next to this, and I'll also reduce this to a smaller size so that I can have better view and I will have more writings. So let's keep it like this. Now I'm going to put some random values for s. So first I'm going to put s equal to 1 on both sides. So this side is always going to be 1, that is on the left side we will have 1, and on the right side when you put s equal to 1, this term as well as this term as well as this term, these three terms will get cancelled, because we have s minus 1. When you plug in s equal to 1, 1 minus 1 will become 0. So wherever we have s minus 1, those terms will get cancelled. So finally we will be left only with the d times of s squared, that is 1 squared. So this implies 1 equals d times of 1. 1 squared is 1, so we get d equals 1. Now let me put s equal to 0 onto both sides. And when we put s equals 0 on both sides, we see that this term will get cancelled because we have s term, and this term will also get cancelled because we have s squared term, and this term will also get cancelled because we have s squared term. So 0 squared times d is 0, and we'll be having only this term which has b constant. So on the left side we will have only 1, and b times of this is 0 minus 1 quantity squared. So this implies 1 equal to 0 minus 1 is negative 1, and negative 1 quantity square is just 1, so b times 1 is b. So we found the value of b equals 1. Now let me put s equal to 1 into the equation. I'm sorry, I'm going to put s equal to 2 because we already put s equal to 1. So on the left side we will have only 1, and we have to replace s by 2. So therefore this becomes a times of 2, and this will become 2 minus 1 and quantity square, which is 1, plus b times of, this is once again 2 minus 1 is 1, 1 square is 1. I put this as 1, plus c times of, this is 2 square times 2 minus 1, which is 1, plus d times of s square, which is 2 square. So let's simplify this. We have 1, and this equals 2 times 1 is 2, and times a is 2a, plus b times 1 is b, plus 2 square is 4. 4 times 1 is 1, and multiply with c, we get 4c, plus 2 square is 4. 4 times d is 4d. Now we can simplify this equation further by substituting the values of d and b as 1. So let's do that. This equals 2a, plus b is replaced as 1, plus 4c, plus d is replaced as 1. So 4 times 1 is 4. Now let's rewrite this by involving only a and c variable. So we have 1 plus 4 equals 5, and we can subtract 5 on both sides. So therefore this becomes 1 minus 5. We will have negative 4, and this equals, we have already subtracted 5 from this side. So we will have only the variables, that is 2a plus 4c. In fact, we can rewrite this as by dividing both sides by 2, and when we do that, we get negative 2. This equals a plus 2c. Or else we will write down in this form by having the variables on the left side, that is a plus 2c equals negative 2. Let's say this is equation number 1. Now let me put s equals negative 1. So I'm going to put s equal to negative 1. On the left side, we will have 1. And on the right side, we will have a times of negative 1 times of negative 1, negative 1. This is negative 2 quantity square, plus b times of negative 1. Negative 1 is negative 2. So it is negative 2 square, plus c times of negative 1 square times of negative 1. Negative 1 is negative 2, plus d times of negative 1 quantity squared. So let's simplify this. This is negative 2 square is 4. 4 times negative 1 is negative 4. So this is negative 4a, and this will be negative 2 square is 4. So 4 times b is positive 4b, and this is negative 1 square is positive 1, and 1 times negative 2 is negative 2. So it becomes negative 2c, and this is negative 1 square is positive 1. So it just becomes d. Let's simplify by substituting d equal to 1 and b equal to 1 into this equation. So therefore this becomes 1 equals negative 4a plus 4 times of b is 1. So it becomes 4 minus 2c plus d is 1. So let's simplify this. We have 4 plus 1 equals 5. So I subtract 5 from both sides. So when I do that, I get negative 4. This equals negative 4a, negative 2c. So in fact, we can rewrite this as by dividing 2 by dividing by 2 on both sides. So we will have negative 2. This equals negative 2a, negative c. Let's rewrite this by having variables on the left side. So we will have negative 2a, negative c. This equals negative 2. Let's say this is equation number 2. So now that we got two equations, that is two system of equations in variables a and c, we can solve them by substitution or elimination method. I'm going to do by elimination method. So this first equation I'm going to multiply by 2. So therefore it becomes 2a plus 4c, and this equals negative 2 times of 2 is negative 4. And I just write this second equation as it is. So it is negative 2a, negative c, and this equals negative 2. Now let's add these two equations. So positive 2a and negative 2a, this will get cancelled, and 4c minus c, and this equals 3c. This equals negative 4, negative 2 is negative 6. So we get the value of c equals negative 6 by 3 is negative 2. So we found the value of c equals negative 2. And this means we can now find the value of a by substituting either in equation 1 or equation 2. I'm going to substitute in equation 1 to determine the value of a. So a plus 2 times of c, c is negative 2, and this equals negative 2. So I have a negative 4, and this equals negative 2. So I add 4 on both sides. So it becomes a equals 4 minus 2. This is 2. So we found the value of a equals 2. So now that we have determined all the values from a, b, and c and d, we can substitute into our original partial fraction decomposition. So I'm going to replace the variables a, this is b, this is c, and d. So a is replaced as positive 2, and b is replaced as 1, and c I can replace this as negative 2, and d is replaced as 1. So we have obtained the partial fraction decomposition for the expression inside the integral. And this means we can rewrite our original integral as 1 over s squared times of s minus 1 quantity squared, and this ds. This equals integral of 2 over s plus 1 by s squared minus 2 over s minus 1 plus 1 over s minus 1 quantity squared. And this we integrate. We also put this ds. Now we can apply the properties of integrals. That is, we have sum of the terms. If we want to integrate the sum of the terms, we integrate each term one by one. So I can put this as integral of 2 over s ds plus integral of 1 over s squared ds. I put negative of integral of 2 over s minus 1, plus we then have integral of 1 over s minus 1 quantity square. And we also have to put the ds. I just forgot to put ds here. Let me put. So this is we can put this positive. Let's integrate each terms one by one. This is a square. So first let's factor out all the constants from each of the integrals. We have constant 2 here as well as this 2 here. And so when I do that, I will get 2 times of 1 over s ds. We just have to integrate 1 over s, that is our first integral. And this expression, I'm going to rewrite this as integral of s raised to the power of negative 2, so that I can apply the power rule. And similarly, I factor the 2 out of this integral, and I just put 1 over s minus 1 plus the last integral will be integral of, I'm going to rewrite this as s minus 1 raised to the power of negative 2 ds. So I put this ds for this term as so. Now we will apply the standard integration formula, that is integral of 1 over x dx. This equals natural logarithm of absolute value of x. So therefore, if we use this formula to integrate the first term, we get 2 times of natural logarithm of absolute value of s. And for the second term, we have to use the power rule of integration. That is, if we have x raised to the power of n dx, and this equals x raised to the power of n plus 1 divided by n plus 1. So I'm going to use this formula. So therefore, this becomes s raised to the power of, we just have to add the power by 1, minus 2 plus 1, and divide by the same number, that is negative 2 plus 1. So we have integrated the second term, and for the third term we can use this formula, that is if we have 1 over x minus 1 and we have to integrate this according to this formula, this will be natural logarithm of absolute value of x minus 1. So I applied this formula here. So therefore this becomes 2 times of, and just use the same color. So this will be 2 times of oh, natural logarithm of absolute value of s minus 1. This is, in fact, I don't need to put this bracket. So it is simply 2 times of natural logarithm of s minus 1 plus for the last integral, we can in fact use this formula. That is, suppose if we have ax plus b raised to the power of n, and we have to integrate this, we can use this formula. So the formula says ax plus b raised to the power of n plus 1 divided by n plus 1, and then multiply with 1 over a. So let me use this formula. When I use this formula, I see that this factor is a linear factor where a equals 1 and b equals negative 1. So when I apply this formula here, which says that ax plus b, that is the same factor. So I put s minus 1 raised to the power of n plus 1. So here n equal to negative 2. So therefore it will become negative 2 plus 1 divided by the same number, that is sorry about it. This is negative 2 plus 1, and then multiplied with 1 by a. The a is the coefficient of s. So here it is, the coefficient is 1. So it is just 1. And finally, we put this integration constant c. So let's simplify this. We write the first term as it is. This is the first term. This cannot be further simplified. So I write down this as 2 times of natural logarithm of absolute value of s. And for the second term, negative 2 plus 1 is negative 1. So it is s raised to the power of negative 1 divided by the same number, negative 1. So this can be rewritten as negative 1 over s power 1. So it is negative 1 over s. So I write down the second term as negative 1 by s. And the third term, we can write it as it is, which cannot be further simplified. So it is negative 2 times of natural logarithm of s minus 1. We put this in absolute value. Just move this expression a little bit higher so I get some more space. So then we can simplify this final expression. That is, we have s minus 1 raised to the power of negative 2 plus 1 is negative 1 divided by the same number, negative 1. So this is equivalent to negative 1 over s minus 1. So I'm going to put, this is not positive, it is negative 1 over s minus 1, and we finally put this integration constant c. So therefore, this is the result of the given integration. So this final expression is the result of given integral.